What's up, guys? Today we're going to be taking a look at designing schematics and PCBs using a software called KiCad, which you can see right here. Some people also say KiCad. I have no idea which one's correct, so I'm probably just going to switch back and forth so I get it right at least some of the time. So if you haven't already downloaded it, you can just go to KiCad.org and you can download it for whatever your platform is. They obviously have it for Windows, Mac OS, Linux, and really any operating system. So once you've got that downloaded, you'll open it up and it'll look like this. Now, as you can see, there's a few tools because the process of making PCBs has a few different steps. So the first step is creating a schematic with the different symbols for the resistors, LEDs, etc. And so you can obviously edit these symbols as well, create new symbols for new components. And then you'll actually create the PCB itself, like running the tracks all around to get to the different components. And that will require footprints, which are basically just the part of the component that intersects with the board. It's called a footprint. So there's those little circles that you will actually connect the components to. And we'll go through all of this in more detail later on, but I'm just giving you a brief, quick overview first. Then you'll create the actual production file that you'll send to a manufacturer to actually get them manufactured, which we'll also do later. And that's called a Gerber file. So the Gerber viewer allows you to view those files in an easy way, not like the editing way of the PCB editor. Then there's a couple more things down below. I don't think we'll be using most of these. The main one is the plugin and content manager. If you open this up, you can see there's some different companies that you can get components from. So for example, somewhere in here you can see the KiCad library for Arduino modules. If you're creating like an Arduino shield or something like that, which we'll probably do at some point, you can go ahead and open that, go ahead and install that, and you'll be able to use Arduino components and Arduino boards in your PCBs. There's also the color theme, so if you don't want your eyes burned out by a light mode theme, then you can install something like this dark mode theme. So with all that out of the way, let's go ahead and create an actual project. So you just go to File, New Project, and create your project. I'm going to call mine Basic PCB. And once you have that, the first thing you want to do is open the schematic editor. Now, once you open this up, there's a whole lot going on. You can see buttons all the way down just about every side of the screen. So it can look very intimidating, but when I started this up, I was actually surprised by how easy it was to design these things, especially if you've worked with breadboards and designing circuits there before, but even if you haven't. So basically what you do is you press A, and this, once it loads up the libraries, is how you add all of the different components. Now there's some weird naming schemes that go on here, but let's say we want to add an LED. You can see we can find an LED. Now, obviously, an LED is no good on its own, so we'll need to add a power source and a resistor to protect it and all that good stuff. So if you want to add anything power related, you can actually press P for that. So we could type in VCC, and that would be our just a little marker that says, hey, this is where the voltage is going to come in. And then we could also add a ground marker to say, hey, this is where electricity is going to go out. And then we could, we can press W to open up the wire tool, and then you can just click and draw wires to your various components. So as you can see right now, we have connected our LED to VCC and ground. However, this would probably destroy our LED because we'd be putting too much power through it. So let's go ahead and delete this wire here, which we can do just by clicking on one section of it and then deleting it, and add in a resistor. Now, resistors are just called R, so we'll just click on the R component, and we can press R to rotate our resistor and click to place it down. And then, of course, we'll add in wire for the remaining part, and now we have electricity flowing through our LED and through our resistor. Now I'm actually noticing that we put this in backwards, so obviously LEDs electricity can only flow through them one way. So something like this won't work because the electricity is trying to flow through the LED the wrong way. So we can simply switch this, selecting our VCC flag and connecting it right here on this side, and then selecting these wires, removing them, and connecting our ground flag, which would probably be easier to see if we rotate it around like this using the R key, to right here. And okay, it's a little tight, so I'm just going to move these components out a little bit. The nice thing is it does have a nice grid snap, so if this looks like it's aligned with these, then it will be aligned with those. Okay, so now we have power going through our resistor, through our LED, and out to ground. We can also adjust some of the things on the LEDs or resistors by hovering over them and then pressing E for edit. Now, the first time you open basically any window in the software, it's kind of annoying. It has to load for a second, but then any subsequent openings of the window, it'll be super fast. So here we are on the LED editing it, and you can see there's a few different things here. There's the reference, which is usually the name of the component. In this case, this is a diode, so D, the first letter of that, and then a number. This reference has to be unique for every single component. So if we had 10 LEDs, it would be D1, D2, D3, and so on. Then there's the name of it, which we can actually change. That doesn't have to be unique. So we could call this LED and all the other ones LED, and that'd be fine. Or if this is something like a status LED, since it's always on because it's connected to power and ground, we could call it status LED. And that's all we're going to do here for now. Let's go ahead over to the resistor, because obviously there's some other properties here that we might want to change. For example, the name. We don't necessarily want it to be called R. We might call it resistor, make it a little clearer what we're talking about. Now, we could go ahead and make this into a PCB. This is how simple it is. Any circuit you can make, you can go ahead and make a PCB off of that. It's really not difficult. So yeah, let's just go ahead and do that just to see how it works. Now, the first thing we need to do is we need to run a check to make sure that this is actually a valid electrical circuit. Because if it's not, then a PCB that we built off of it won't actually work. And it's super easy. You just, not that. You go to this one here that looks like a checklist and has a check mark. That's the rules checker. And when you open it up, you can press run ERC for electrical rules checker. And there you go. You can see we have 2 mistakes. And these are also shown on the schematic by these little red arrows, which is very handy because even if we close this, we'll still have the red arrows. Or if they're just warnings, which are things that are not necessarily a huge issue, then there'll be yellow arrows. So if we go ahead and look at what it says here, it says hidden pin power input line. And what this means is that with KiCad, the way they want you to set up power and ground connections is they want you to always have what they call a power flag that just says, hey, this is power. To a human, it's quite obvious that VCC and ground are power in and power out, but to their program, it's not that obvious. So I think if we press P, we can try to type power, and yes, here's power flag. So then we'll add this in addition to the VCC on that side there, and we'll do the same thing in addition to the ground on that side there. Okay, now obviously it's getting it a little bit clustered, so I'm just going to move this farther away. And remember, this isn't the actual PCB. This is just a schematic representation. So it's more important for it to be legible than it is pressing M to move it here, than it is for it to actually have a reasonable layout that will work on a PCB, because we'll do all of the laying out in the PCB editor. That's the beauty of the separation of the schematic and the PCB. We can make the schematic look super nice and easy to read for our, I don't know, fellow employees who are going to be working on this with us or whatever. And we can also have a PCB that makes a lot of logical sense. All right, so once again, we can open up the electrical rules checker and click run ERC. And as you can see, the violations are now cleared out to 0. So if we press this button here that looks like a PCB, we can open up the PCB in the board editor. Quick note here, guys, if you have any questions at all, go ahead and send them in the chat. I'm somewhat monitoring it, so I'll see it hopefully as soon as you send it and be able to respond to it. So if you have any questions at all, just stop me and I'll address them. So what we want to do here is we want to add all of the components that we made in our schematic. So if we press this button here, which is half schematic, half PCB, then we can update the PCB with all of the changes that were made to our schematic. And as you can see, we have gotten some errors. The thing is, this button here puts us back in the schematic editor. The thing is that each of these components is basically a logical component, like a resistor or an LED. That's a abstract concept. In order to put it on the PCB, we need to know exactly what the physical object that we're using for a resistor or for a LED is going to look like in physical space, and what space it's going to take up, so that we can actually fit it onto the PCB, which will eventually exist in the real world. So what we're going to do is we can once again press E over these to edit them individually, or we can go up to this button here where it has like a little symbol, little footprint. That's a symbol for like footprints right there, because the little blue things are like where the pins of that IC would go in. And we can click on that. And guys, we'll be doing this several times, so it should, you'll get used to it after doing it a few times, and you won't have to mouse over and look at what all the little things are called. And then inside of here, we can see all of our components, which in this case is just D1 and R1, and we can assign them with footprints. So when we click on D1 here in the center, components are in the center, we look on the left for a category, and we look on the right for a specific type from the category. So on the left, we have selected in the middle, we've selected our D1 diode. Then we want to look on the left for probably a diodes thing, unless there's an LEDs thing. I think it's just diodes. So we'll click on diode THT. Now, if you don't know, THT means the components that are like the components we'd use with a breadboard. So like I have THT LEDs right here. Here's a yellow one. Yellow. Okay, wow, you really can't see that. It's just like the typical standard. Okay, yellow was a bad choice since I'm on green screen. Let me try red. It's just like the standard LED that you would use on a breadboard. That's a THT component. Anything with pins that stick down like that, whether it's an LED or a resistor or something like that. An SMD component is something like you'd find on on the actual board of an actual Arduino board. So if I can pull out an example on this little board, this is like a mic board. These components here, they don't have pins that go through, they just have pins that lay on pads. Same with these components here on the side. None of those components have pins that go through, instead they have pins that set on, and that's an SMD component. So THT components are easier for humans to solder because they can stick the pins through and then apply solder. SMD components are generally much smaller, and they're better for machines to solder. So once we've selected THT, because we want this to be human solderable, we can see there's a whole bunch of options here, not as many as in some categories, but a pretty good amount. And these are the different options for what size our LED could be, and like what rotation it could be, whether it's standing up straight like this, or whether it's maybe bent over like this, you know, with the head here and the leads sticking down here. So what we want to do is we want to look for, since that was a 5mm LED I just showed you, let's look for a 5mm, something that says 5mm. Interesting. I forget which one of these I usually use. I think it's going to be 5.08mm. And let's just we'll have to check and see what this looks like in the PCB editor. Anode up, vertical. I assume vertical is correct, as it's the LED should be sticking up. That's what we want. 5.08mm. That sounds pretty good. So we double click on that to actually confirm that that's what we want. The other thing we can do is we can right click and click view selected footprint, the only option there, and here we can see our footprint. So you can see here we have the anode A and the cathode K, and these are just the two legs of our LED that we would put through and then solder. Also, if we press option 3, then we can see what the 3D model of our LED looks like. Now, keep in mind, this is diodes here. I think that I selected the wrong category because obviously this is a diode that does not emit light, and that is not what we want. So let's scan through and see if maybe there's an LEDs specifically category. Yes, LED THT. Okay, that's much better. So they did separate out the LEDs that actually have light, and that's what we want. So let's look in here for a 5mm LED. That seems much more promising. Here we go. We have some rectangular ones. Here we go. We have just a diameter ones here that just say diameter, so that seems good. Diameter 5mm. Sounds good somewhere in this column. Clear sounds good. So let's do a THT LED, one with the pins that go all the way through. That's 5mm in diameter and is clear. I'm going to double click on that and just once again check view selected footprint. And as you can see, it's round and has the flat side, just like our LED does, to show, because you know the flat side on the LED is the minus side, so we can see more easily on the PCB with these lines here how we're supposed to put our LED in. And then if we press option 3 to go into 3D view, that's exactly what we're looking for. Okay, so now we've got, after all that, we have our status LED and the correct footprint for that. So now the PCB will know which type of LED we're going for, or which type of diode, because it could be any type of diode based on this schematic. That's why we need the footprint. Now I want to add a resistor, and this one should be easier because it's just resistors. So we'll go into resistor THT, and we will look for, I think what we want is the axial 0207. One of these, I would generally just Google what people are using for assembling Arduino stuff with these, because lots of people have assembled stuff with these little resistors like we're using. So you just have to look up what other people are using and base it off of that. I believe what I used last time was this one, the R axial DIN 0207. Length, I think, what length is good? Sure, let's just say it's 6.3mm. We probably want it to be horizontal though, because I think that's it. So I'm going to double click on that, view selected footprint. This looks promising. Body, 2 pins. Obviously, the pins are just labeled 1 and 2 because it doesn't matter which way you put it in, and there we go. There's our resistor. That looks good. So let's go ahead and go with that. Now, if we click OK there, now when we go over to the PCB editor once again, it'll know what physical components we're actually shooting for this time. And we can go ahead and import those, update the PCB, and click close. And it'll go ahead and put these on our mouse for us so we can see them. Now, in our circuit, we have a power and ground things. But if we go back to the schematic with that schematic button, we don't have anything physical to represent how we're getting in the power and ground. Now, obviously, there are lots of ways to do this. But let's maybe look for some... not actually sure. Let's look for maybe some pin headers. We have, here we go. All of these ones where it says connection, well, we actually want one row ones. Connection 01 by whatever. That's standard pin headers spacings like we would have on an Arduino board or on a shield that's supposed to fit onto that. So when we go ahead and look for the footprint of this, we could say, oh, I want this to be a male header or a female header for the purposes of the design. But either way, the whole spacing will be the same. So let's go ahead and put in 01 by 02 pins, since we only need 2 pins here. And if we put that in place, we can hover over it and press E to edit, or since it's already selected, we don't actually need to hover over it. And we can rename this to power and ground. I should name this VCC and ground. And that'll be what those two pins are going to be. So once we have those, we can change our wires to be connecting. We can change our wires to be connecting up to those two. So what we want to do here is we want to create labels. Now labels are basically a little portal. You can put a wire up to a label, and then you can put another label somewhere else, and it's like the wire's just coming out of the it's like the wire's just coming out of the portal on that other end. So let me show you what I mean. If I create a wire here, just stretch it out a little bit, and then double click to end it in open space. Same thing here. Stretch it out, double click to open it to end it in open space. And then press L for label. We can create a label. And what I'm going to do is I'm going to call this ground, GND. And I'm going to click it, making sure that the positions are lined up for it to be on that spot right there. I'm going to press L again to create a VCC label, and I'm going to put it right there. Now what we're doing here is we're sending these wires into the ground portal and into the VCC portal. And then what we can do is we can, I think we can actually just delete this one right here, this VCC thing. We still need the power flag. Actually, if we extend the wires out a little more, just thinking about how we can make this look the best, we can select this, press M to move, and put it right here. And then once again, select this. Select not the whole thing, just this. Press M to move, R to rotate. Let's have it point down. And, well, actually, why don't I just have it point the same way, and I'll just put it lined up here so it looks nice. And then we can just draw the wire across here. Now, it goes through these two flags and into the power flags, so KiCad knows, hey, those are power-related things. Then, if we go ahead and delete these and that, we can stretch this out, double click to end it, press L for label, and create a second ground label. And now this wire here, which has ground on it, which is notified as power to KiCad using this, is now also connected here, as if we had just stretched a wire down to here. But we didn't, so it looks a lot better. And same thing here, L for creating a label, call it VCC, and connect it here. You can connect it anywhere on the wire, it doesn't really matter. And the wire can go off, because remember, this is just it's just a logic thing. It doesn't actually matter. There's nothing physical about this. The physical parts are all in the PCB. Okay, so since we've changed stuff, we do want to run the electrical rules checker again to make sure we didn't make any mistakes. In this case, we didn't, so we can press the PCB looking one to go over to the PCB editor, and then once again, we'll need to update. And when we press update, it'll go ahead and add in, okay, we forgot our footprint again. So schematic looking one to go back to the schematic, and we need to add a footprint for this as well, because we didn't tell it whether we want male headers, female headers, like which type of header pin we want to actually put on there. So we can press E to edit this, and there's this footprint field here, which if we click on the little library stack here, it'll let us choose something. Once again, all the way on the left here, we have the different spots, different like folders basically, where we could find stuff in, and we're looking here for a connector. Just general connector seems good. Maybe we want to find like a more specific pin header. Yeah, connector pin or connector pin header. Yeah, connector pin header should be perfect. So we want the 1x2. And as you can see, there's different options once again. There's horizontal, which is going to kind of stick out, or there's vertical, which is obviously straight up and down. So if we double click a vertical, we can select that, save it, go back to the PCB, run the updater again, click update, and now here we have this little 1x2 pin header. It's called the VCC and ground and has the VCC and ground. And you can see what KiCad has done for us is Once again, hovering over something and pressing M allows you to just kind of grab it and move it, and it'll bring along all these little letters and stuff that go with it. It'll draw these faint lines to let you know where your connections are supposed to happen. So you can kind of position your components roughly if you want, roughly where you want them to be. So as you can see, these two lines are crossing over each other, which is hard to do. So like we don't exactly want to do that if we can help it. So we can press R to rotate this resistor around, and now you can see they're making like a nice triangle here. No lines going over each other. So we could go ahead and assemble them. Now keep in mind, this is how your finished PCB is going to look, whatever this arrangement here is. And I actually just noticed they're also crossing down here. So I think the triangle should be like this. VCC to VCC, here to here, and ground to ground. Yeah, that should be right. Now there's no overlapping. So then we can kind of arrange these how we want to make it look a little better and be more compact, because obviously smaller PCB costs less. So this seems like a pretty good arrangement. Now let's just explain the layers next. So as you know, probably know, maybe you don't know, a PCB is made up of different layers. So we have the copper layer, which is the conductive layer that all of the components are going to get connected onto, so that the electricity can run between them. And the copper layer will be shaped in such a way that there's little, traces and lines going all around. The copper layer is basically like when you do wires on your breadboard, it's the wires. Then we have a couple of other layers. There's the mask layer, which is what goes over the copper. So that covers the copper so that other things outside can't just touch the copper and mess up all your electrical connections. This is obviously trimmed out around the circles where the pins are, or squares where the pins are, in the case of these square ground pins. And then on top of that mask layer is a layer that is printed words. So of copper covered, that's this gold stuff, covered in most places by a mask, which in this case is green, but uncovered in some places. And then we have the silk screen, which is these little lines on here, which are all white. And this can be words, symbols. If you want to put your company logo on there, you would do that with a silk screen. It just, after you print out the PCB, you draw those things on there, so it's easier for the assemblers. Yeah, so those are the main layers we're looking at here. Now, depending on how many layers your PCB means, the layers count that that your PCB has is the number of copper layers it has. So if you had another copper layer, that would be like having another set of wires disconnected from the first set of wires. So there's two copper layers that aren't connected except in some places, so you can have traces cross over each other. If you just have one copper layer, everything is on the same plane, so you can't have a trace cross over another trace, or that they would touch each other, and that would probably cause a short or something. So that's what I was saying about these components. Since this is such a simple design, we would like to do just a one-layer PCB, which means none of these lines can cross over each other. So if they were in that organization before, something like this, it would be really hard because these two lines cross over each other. We'd have to figure something out. Now, these lines here are obviously not optimal for how the traces are going to be routed. You can't do lines like that. Usually you have the lines going along a certain grid, so it's easier to manufacture. So what we actually have to do is we actually have to draw out the lines that we want our traces to go on. So if we click this tool here, that's a line, KiCad calls them tracks instead of traces for some reason. But then we can click on this pad that we're starting from, and we can go over to the pad we're going to, and it's just like that. One thing you want to be careful of is you don't want a 90-degree angle like this. Now, KiCad typically won't let you do that, like it'll try to have that not happen. So if I just click and drag, it'll do a diagonal automatically, but if you click down, then it'll put a corner there. So you can see this part right here over on this side is going to be dimmer and the part on the other side is going to be a little bit brighter. So then it'll try to preserve the corner location that you set. It won't always be able to, but it'll try to preserve that and still make something that works. So now we have the little angle happening a little bit earlier down the line, which doesn't really matter. But if you were to intentionally click down like this and then go like that, you would have a 90-degree angle, and that's not what we want. That's very likely to get messed up. So don't have 90-degree angles in your tracks. Go with 45-degree angles, just like this, and that's what KiCad will try to do. And this one's super easy, so you can see you just click down to start, click down to end. Like with the other wires in the schematic, if you want to end in open space, you just double click and it'll just leave it there chilling. Obviously we don't want that, so we can just delete it. And now if we go into 3D view, we should be able to see the traces. Yeah, here we go. You can see that there's basically, it's trying to simulate a thin layer of mask over this copper, so you can kind of see the copper still. And this is what our PCB would look like if we were to manufacture it right now and solder on these components, except that there's no solder. And we would connect the ground VCC to one of these and ground to the other. However, it's not very clear which of these is VCC and which of these is ground. Obviously, we could figure it out by looking at the LED here. We can see, oh, this side is flat, this is square, this must be ground, so the ground pin should be this one based on the track. But we don't want our assemblers or whatever to have to do that. So what I'm going to do is, first I'm going to clear out all these extra pesky words because I don't like them being here. And you can see those 3 words. They are not in the schematic because they are on the drawings or comments or something layer, as signified by the fact that they're light gray. The ones that are on that drawings layer, or the ones that are on the silkscreen layer, which actually gets shown, are these ones that are kind of a pale yellow color. So if we hit option 3, we can see nothing changed about the PCB because we didn't edit, we didn't delete anything that was already being, we didn't delete anything that's being drawn on here in silkscreen. You can see we have the J1 here and these little yellow outlines to kind of show where the pin header is going, and the resistor outlines and everything like that. So if it's this light yellow color, which is right here, f.silkscreen, if it's that color, that means it's going to be drawn on there. And if it's like this light gray color or something like that, it's not going to be drawn on. Okay, so what we want to do is we want to create more stuff that's being drawn on. Now, one thing we could do is we could repurpose this. If we don't like there being a J1 there, we could change that by pressing E over it, and we could type something else there instead. You can see when we edit it, it shows which layer it's on. So if we were to switch this to f.fab, I think is what the others were on. Now, if we go into option 3, 3D view, it's not shown because it's not on the silk screen. So obviously we want to edit that again, change it back to the silk screen, back to showing up, and beautiful, it's back. Now we want to add more labels. So, well, more text explaining. So if we press, what is it? Is it L? Let's go back to this editor and we can press T to add text. I'm not sure which editor you generally add these sort of labels in. If we press A, we could try searching for something. No, that's not it. Let's try adding a quick text here and see if it transfers over to the PCB. So we're trying to add ground and VCC labels for this thing. So go ahead and duplicate that, edit it, VCC, and enter doesn't work because it's a multi-line. So now we have them in here. Let's see if when we go over it actually will import them. I'm not sure if it will. I think it did. Were these here before? These might actually have been here before, this one and this ground. How do you add these custom labels? Well, we can click this T here and add text. I guess the T shortcut just doesn't work in this editor, and that's all it is. So if we click the T over here, we can add text, and you can see the default layer is the silk screen. So if we go ahead and type GND for ground, we can line it up with this ground here, and let me just put it up a little. And then we can Command D to duplicate that, or Control D, and edit it, call it VCC. And there we go. Now we have labels on both of those pins. So if we press Option 3 to look at 3D view, it should be super easy for us to see once we have the PCB in our hands. Oh, I should put the ground wire here and the VCC wire here. Now, another thing we could do is, if this is supposed to be specifically 5 volts, is when we go back here, instead of having a, well, here we're not actually showing any power source. So we could just edit this and say something like plus 5V, and that'll just let our users know. If we go into Option 3, that'll just let them know, oh, this is supposed to be plus 5 volts. Now you can see it has here an error, and this is a good time to run the DRC, which is the design rules checker. So in the schematic, we have the electrical rules checker, and in the PCB editor, we have the DRC, or the design rules checker. So if we run the DRC, we can look for any errors. And here we go. Once again, red arrows point to errors, and yellow arrows point to warnings. So here we have some errors, and the issue here is that the silk screen here is overlapping with the area that's reserved. I think that's the issue. Let's go back to our rules checker. Yeah, I think the issue is that the clearance here is too much. We can see this yellow arrow here. The yellow arrow is because these two things are overlapping, so I'm just going to change it to 5 volt and then move it back somewhat close, and then save that. And now if we run the DRC again, it'll get rid of this yellow error, the yellow warning there, and we can see another error is because we didn't actually define the edges of the board. So I guess when we go into 3D view, it just comes up with something random that fits all of the things in place, like just a random rectangle that fits all the things in place tightly, but we didn't actually tell it what size or shape we want the board to be. So what we can do is we can go and tools, we might just want to grab this rectangle here on the side. That's okay. When you grab the rectangle, you click to place one corner, and then you click again to place the other. Now, and as you can see, if we press E while hovering over it, the layer it's on is edge.cuts. That's the layer that defines the cutting out of the board. So now if we press Option 3, we can see, yep, that's our shape there. So one of the errors in the DRC at the bottom here is that there's no edges. Now if we run it again, we actually have edges, so we get that error fixed. And we can just click on this and to rearrange it. We can also add other shapes, so we could add a circle. You click and it'll put the center there, so now we just have 2 random curves there. Okay. I think it doesn't like the overlapping here because it doesn't know which parts it's supposed to keep and which parts it's supposed to remove. So if we edit this, filled shape maybe, and then we let's check the DRC with filled shape now. See if that. Oh no, that's not okay. Let me just for the moment move that away, actually delete it, and let's resolve our errors that we're having here right quick first, before we go play with fun board shapes. So the error here is we don't have enough clearance. There's supposed to be 0.2 millimeters of clearance, but there's actually only 0.15. So this is actually an issue with this this footprint for pins, pin headers that we've designed. It should be because these two pads are placed too close together for our tolerance to allow for that. So we need to mark the tolerance as more precise, so when we go to actually manufacture it, it uses more precision to make sure that it's actually accurate. So we can change the rules for our PCB. If we, I think it's the settings one right here. Let me see if I can find it in the menus as well. Might be no, that's for printing. Let's look for, board setup. It's called board setup. So here we can change the layers for the board. As I mentioned before, you know, there's the copper layer, there's the silkscreen layer, all of those kinds of things, and we could change what finish, all these kinds of things. But down at the bottom here, we have the design rules, and these design rules are what the clearance is allowed to be and things like that. So if we cancel out of that and go back to the DRC, we can see the default clearance needs to be 0.15 in order for us to actually use this component here. So if we go back to our file board setup, we should be able to change not that, the minimum clearance. I guess if you set it to 0, it might use the default. So if we change it to 0.15, I think that will fix our issue, because we'll be telling it, hey, we need a precision of 0.15 in order to manufacture this, and that should be possible. Okay, that wasn't quite the right one, so let's close that again. Back to our board setup. This button here is also board setup. For some reason, it's grayed out when you're using the rules checker, so you have to close that in order to be able to access the board setup. Oh, here it is. It did say net classes on there, didn't it? So we can change this to 0.15. None of these other ones are giving us any issues. So then when this file is output and it's, you know, uploaded to some PCB manufacturer's website, it'll check and it'll make sure that it's using the correct precision to actually be able to manufacture this. And obviously, if it was too insanely precise, like 0.0001 millimeters or something, then no manufacturer would be able to actually fulfill that. But 0.15 should definitely be fulfillable. So here we have it. No errors on the DRC. And it looks good in 3D view. Always check it in 3D view, because you never know when, like with the diode I had before, it was completely wrong. So you never know when you have, whether you have the right components or not, unless you click on 3D view and check it out. So you can see we have the proper setup here, so that when we get it, we can add our own LED resistor and pin headers there, and it'll work. So let's go ahead and output the files in such a way that we could manufacture them. So what we want to do is we want to go to File, Fabrication Outputs, Gerbers. Again, the Gerber file is what is used to, what you give to manufacturers so they can actually manufacture your thing. So first we've got to plot our Gerber file, and yeah, the default settings should be fine for this, I believe. But then in addition to plotting the actual Gerber files, and you can change the directory up here if you want. I'm just going to leave it at the main directory of the KiCad project that we're working on. You can also, you also need to generate the drill files. So for making your PCB, obviously there's holes in the PCB. So the Gerber files will say how the edges are cut and what shape the copper should be and stuff. But you also need a separate drill files for actually putting the holes in the PCB before you do any of that cutting out of copper and whatnot. So you generate drill file here and generate map file. Now, some of the settings here actually do matter. You probably want it to be in alternate drill mode, and I think that's the main one. If the drill origin isn't set to absolute, you probably want that as well. Usually millimeters, and decimal format is recommended as well, so I think that'll be the default. But I would use those settings for when you're generating your drill file and your map file. Now, some PCB manufacturers don't ask for the map file. They don't care whether you add it or not, but you can always add it and it should be fine. So now that we have those files outputted, if we wanted to, we could simply open up the folder where we have those files in, zip that folder up, and send it off to a manufacturer to get it manufactured. Now this, so that's how you make a very basic PCB. If we go back to the schematic editor, I'll just show a few tips and tricks for actually working with this stuff. Obviously, the main thing is if you have a component physically and you don't know what the symbol for it is in KiCad, then you just want to Google something like, if it's something like Arduino specific, like an Arduino Micro, or maybe a component from Adafruit or SparkFun or somewhere like that, you just want to Google that component, and often they'll actually have the files for you to download, or you'll find a forum post somewhere where some user has made something or found what component is represented in KiCad. So again, A to add components, and you can search for them here. So resistor is just called R. Let's say we wanted to add a potentiometer. We could just search for that, R_potentiometer, and as you can see, we get a little 3-pin potentiometer in here. Then E is to edit any of the settings on it. So you can edit the name here, or my potentiometer is what we could call it. And you can edit the footprint either here by clicking the library button and looking for a potentiometer, THT once again. Let's just go with this default one and see what happens. And when you're looking at one of these, if you right click it, okay, here it's already shown, so we just want to press option 3. I guess maybe in this view, oh, there we go. So here they don't actually have a 3D model for it, they just have the pin layout for it. So you might have to do a little more research for one like that. Some of them they do have the 3D models for, and some of them they just don't. So yeah, you can see there's a ton of potentiometer options here. Let's just go back to the one we had. And the other thing you can do to change those footprints is if you press this button up here, which has, again, the footprint symbol, you can run the footprint assignment tool, and you see all of your components here. And for each one of them, you can select a library and then select component. Okay, then for creating the labels, you can press L to create a label, and it's just a little portal that gets you. Now we have another ground connection, and we can press W, double click there. Maybe we want to add in another resistor, and then another LED, not another label. A for add any kind of component, LED, R for rotate, click it down, and then once again we can add W for wire, double click to end it in open space, and then L for label, VCC, and just like that, we've added another LED onto our circuit. Then for adding extra labels that are in the schematic only, you can press T for text, and label is in schematic only. And we can add a label that's just here in the schematic. It's not a label. A label is technically these labels that allow you to make magical connections between wires. This is just a text box that's only here in the schematic. And that's what you can do there. It's the same thing if you draw one of these shapes here, like a rectangle. That's, again, just chilling here in the schematic editor for your for separating items or something like that. It doesn't actually get transferred over to the PCB typically. So if we go over to the PCB, remember we have this button here to update the PCB with any changes we made. And you can see it's brought in our potentiometer, so we should probably extend our board to include the potentiometer, which is completely unconnected to anything. And option 3, to view that, now we have our extra potentiometer connected. And before you add things to the PCB, you generally want to run the electrical rules checker, because it'll give you things like, oh, none of these pins are connected, so it's completely useless. In the PCB editor, same thing, you want to run the design rules checker, and it'll give you things like, if you're missing a connection, like let's say we forgot to add this line right here, it has this line right here that's telling us that's supposed to happen, so we're going to run the DRC. Okay, apparently that's just a warning that the track has an unconnected end and this isn't connected. So yeah, definitely go over the warnings before you send it off to a manufacturer, because you don't want something like that to happen. But it did give us some output to tell us that something was wrong there, and so now we're able to fix it. That's about it for a very basic intro to KiCad, and you've already created a simple circuit model that has 2 pins that connect to an LED, and this thing would work if you had this manufactured. You put in a resistor, put in an LED, put in these pins, you connect the wires up to it, and this PCB would work perfectly well. So yeah, hopefully you enjoyed that basic introduction to KiCad. If you have any questions, send them quickly. Otherwise, I'm going to end the stream.